This is the story of a weather system that affects almost every person on the planet. Every time it appears, it claims thousands of lives. It spreads disease and changes history. It is called El Nino.
El Nino is the most deadly weather event on Earth.
It's a matter of life and death. The dread and fear of the impact of yet another El Nino is quite huge.
It has taken scientists over 100 years to discover just how powerful El Nino is. But now they're making new discoveries about El Nino. Their fear is that it is changing, that it may be getting stronger, so that in the future it will wreak even greater havoc. What's worse, we humans may be to blame. Jennifer Seagraves lives in Laguna Beach, California. The weather here is usually remarkable only for being sunny, day in, day out. But spring 1998 was different. Southern California was battered by days of torrential rain. Finally, on the night of the 23rd of February, it seemed the Earth could take no more. Jennifer was at home with her fiancé, Glenn. Fearing a landslide, they took refuge in a neighbor's house.
I just so vividly remember sitting next to Glenn and just being happy that I was safe. At that point, we heard a big crash. And I remember being really scared because I was hearing a lot of boulders coming down.
The saturated ground began cascading down the hillside in a terrible landslide.
1 second, I'm on the top of the couch, and the next, I was thrown out of the window, a second-story window, and just washed down the hill in a river of mud. And I just tried to lift my head and breathe, and I couldn't. And I realized I was going to die. There was no thought in my head that I would survive.
Jennifer and Glenn were swept out of the house and half a mile down the valley.
The next thing I knew, something had caught on my feet and stopped me. And then I just remember screaming for help.
The emergency services arrived to take Jennifer and other victims to hospital.
I didn't want to go. I wanted to stay and look for Glenn. He hadn't been found yet.
There was no news of Glenn until the next day.
It was the following morning, and they had called and said that they had found a body. And I just remember my brother Jody walking in the door, crying. And at that point, I knew that he was dead.
Jennifer and Glenn's story wasn't the only freak weather event that year. While California reeled under the effect of floods, Queensland in Australia was dealing with the opposite problem. Severe drought had brought ruin to farmers like Rod Saal. Hundreds of his cattle were suffering severe thirst and starvation.
The terrible drought financially crucified us. We had to shoot that many animals on some days that we did not have time to go back and either bury or burn them. So you just left them there. And after a while, the property starts to smell of death. And it was just soul-destroying.
Finally, Rod had no choice but to sell his farm. It was a common experience across eastern Australia.
People in any town you went to were demoralised, depressed, and defeated in a lot of ways. And certainly there were people that took their own lives. There were suicides. There was no two ways about that. And their only way out, yes, was the saddest way.
And it wasn't just California and Australia. From April 1997 to May 1998, the weather all around the world seemed to be going crazy. There was flooding in Peru and in Kenya. Scorching heat in Indonesia caused enormous forest fires, creating a huge cloud of smog, which caused a ferry to sink and a plane to crash. There was drought in North China and in southern Africa. Heavy rain brought major epidemics of malaria to Africa, and 30,000 cases of cholera to Peru alone. The worst floods for over 100 years struck Central Europe, killing 55 people in Poland and 60 in the Czech Republic. To the watching world, the period from April 1997 to May 98 looked like chaos, as if the weather everywhere had spun out of control. But scientists knew better. They knew that all these apparently random events were linked. Working out how they were related was a scientific detective story that had taken over 100 years to piece together. And at the end of it, they would discover one of the most powerful forces in nature. The story begins in Peru, where for thousands of years, fishermen knew of a strange phenomenon. Normally, the coast of Peru is one of the richest fishing areas in the world. Millions of anchovies swarm here, and for centuries, fish have been the Peruvians' greatest resource. But every few years, something mysterious happened. The fish vanished.
Peruvian fishermen noticed that every few years there would be an invasion of very warm surface water along the coast of Peru. And when they noticed this, the fish that they would normally catch disappeared.
And they soon realized it wasn't just the fish that were affected. At the same time, there was a dramatic change in the weather.
On the land, you had heavy rains. And the vegetation would bloom on normally arid, dry soils. The driest desert in the world is along the west coast of South America. But all of a sudden, every once in a while, it would become green.
And there was something else. It always happened at the same time of year.
They also noticed it's a seasonal thing. It starts around Christmas time, and that's why they call it El Nino, because El Nino, which means the boy in Spanish, with capital letters, refers to the Christ child.
El Nino appeared to be a cycle. Every 3 to 5 years, the normally cool water off the coast of Peru was replaced with warm water. This was what brought rain to the desert and ruin to the fishing industry.
Fish populations used to cold waters would disappear, either diving deeper or just dying and not reproducing.
Each time El Nino came, it would stay for 12 to 18 months. For the people of Peru, it was a matter of life and death. Whenever El Nino struck, they would beseech the Christ child for assistance. But for the rest of the world, El Nino was of little interest.
These scientists first described El Nino in the 1890s as a curious Peruvian problem. It wasn't anyone else's problem. They had this local anomaly, and they had to deal with it.
And that's the way it might have stayed. But for one extraordinary man with a penchant for ice skating. 100 years ago, Gilbert Walker was a British scientist of some eminence. An unusual obsession would enable him to make the first crucial breakthrough in understanding El Nino. Walker looked for mathematical meaning in everything. He analysed the dynamics of skating. He was fascinated by the flight of boomerangs and constructed equations to describe their movement. He did the same for the flight of birds. He even studied the physics of the flute and changed its design. In 1904, his faith in maths was about to receive its toughest test. At the end of the 19th century, the British Empire dominated the world. But in its most prized territory, India, there was a problem. All India's crops, indeed the entire economy, depended on the monsoon, the annual season of heavy rain. But in 1877, the monsoon had failed, and the resulting famine killed 5 million people. When it happened again in 1899, the British government decided action had to be taken. They believed there might be a way to predict the monsoons, and they asked Gilbert Walker to find it. For Walker, it was all about maths. If he could find mathematical patterns in the weather, then he could perhaps predict the arrival of the monsoon. But to find these patterns, he realized he needed to look further afield than just India.
What he realized was that in order to predict the rainfall in India, he was going to have to look at the weather from much wider around the globe. So he essentially got together all of the weather records from all of the places around the globe and started to look for relationships between the weather in different parts of the globe.
And so Walker looked at the records for places as far afield as Australia, Mauritius, Zanzibar, and South America. What he was looking for were mathematical correlations between the weather in different parts of the world. But there were just too many numbers, far more than in the motions of skating or of birds in flight. Walker was overwhelmed by the sheer quantity of data. There was just too much to process. Finally, he got an unexpected opportunity. With the outbreak of World War I, many of the British workers in India returned to Europe to fight. Administrative duties at the Indian Met Office were scaled down, and Walker found himself with a pool of Indian staff with time on their hands. And so he taught them how to do statistical correlations and set them to work on his mountain of weather data. He turned them into a human computer. And out of all these statistics, a pattern finally began to emerge. It all hinged on atmospheric pressure.
During that study, he noticed that when the atmospheric pressure in the central Pacific went up, it tended to go down over Indonesia and North Australia, and vice versa. And he noticed that there was this seesaw in atmospheric pressure between the central Pacific and Indonesia, and he noticed that it occurred every 3 to 5 years.
Normally, pressure was low near Asia, bringing rain and storms to Indonesia, and high near South America, which brought dry and clear weather to Peru. But just like El Nino, every 3 to 5 years this pattern reversed. Walker called his discovery the Southern Oscillation. It was a revolutionary concept. The weather on either side of the Pacific Ocean, thousands of kilometers apart, was in fact linked together.
The amazing thing about Gilbert Walker's work was he's really one of the first people in the climate business to think big, to really link the weather together on different continents.
There even seemed to be a link to the monsoon. Often, when the southern oscillation reversed, the monsoon failed. But neither Walker nor anyone else knew that his discovery would one day transform our understanding of El Nino. People simply rejected his ideas out of hand.
These grand ideas from Gilbert Walker were very much criticised at the time because people just didn't realise that the weather and climate in one area could be completely linked to another part of the globe, and they really undermined him for this.
Walker's ideas were ahead of their time, so the man and his theories were forgotten. It would take another 50 years and a little piece of luck before Walker's genius would finally be recognised. It was the United Nations that would unwittingly spark the discovery of the next clue in the El Nino story. In 1957, they announced a plan that would transform our knowledge of climate. It was called International Geophysical Year.
The United Nations decided to look at the oceans, the atmosphere, the land, to try to learn more about planet Earth.
As part of this great plan, they placed a series of research buoys across the Pacific Ocean. The idea was to see how ocean temperature changed. It turned out, by a piece of good fortune, that 1957 was a particularly good year to measure temperatures across the Pacific.
The interesting thing was that by accident, they happened to pick a period of time when there was a major El Nino taking place. 1957-58 is one of the major El Nino events of the 20th century. So by accident, we were able to get some good information about El Nino and its impacts.
For the scientists, it meant they were taking their measurements just as El Nino hit the coast of Peru. And as expected, they found the sea temperature warmed up. But then, as they looked at data from other buoys across the Pacific, they found something else.
For the first time, they discovered that the changes in the East Pacific off Peru were not just local, but really impacted the whole of the Pacific. And the Pacific is 16,000 kilometres wide at that stage, and they were completely surprised to see how big El Nino really is.
It was a major discovery. El Nino wasn't merely a local Peruvian phenomenon, but seemed to stretch right across the Pacific Ocean. They soon realized that as the water warmed up off the coast of Peru, it cooled down on the other side of the Pacific.
They discovered that normally there's cold water off Peru in the East Pacific and warm water off Australia and Indonesia in the West Pacific. Now, when an El Nino happens, this warm layer sloshes back across the Pacific, and so warm water appears off Peru, and colder waters can appear then in the West Pacific.
But just as with Gilbert Walker's discoveries half a century earlier, no one realized that these changes might be part of a bigger pattern. What was needed was some creative thinking. In the 1960s, Jakob Bjerknes was head of the meteorology department at the University of California. He'd spent his life studying weather, and his skills were in demand.
In the middle of the 1960s, Jakob Bjerknes did some consulting for the Tuna Commission that wanted to better forecast where tuna could be caught and where their breeding grounds were and how they reacted to weather and ocean conditions.
Bjerknes took his tuna tracking work seriously. He gathered all the information he could about the Pacific and the weather around it. Amongst all this data were the UN's El Nino records from 1957 and the work of Gilbert Walker.
All of a sudden, a light went on in his brain, and Bjerknes linked sea surface temperature changes to major changes in the atmosphere above the Pacific Ocean.
who was the first one to really make this connection that the El Nino might be linked to these cycles that Gilbert Walker discovered, these changes in the atmosphere.
Bjerknes had made an extraordinary leap of imagination. For the first time, he connected two previously separate phenomena: El Nino in the Pacific Ocean and Gilbert Walker's southern oscillation in the atmosphere above it. Bjerknes realized they were both part of the same giant system. Under normal conditions, the warm water stays in the west, and the winds across the Pacific blow from east to west. This creates an area of low pressure around Indonesia, which brings clouds and rainfall. But when an El Nino happens, everything is reversed. The wind direction changes and the warm water moves towards Peru, taking the low pressure and heavy rain with it. And it's this movement of air pressure and warm water which brings floods to Peru, drought to Australia, and storms to California. In fact, the more scientists compared the weather around the world with records of past El Niños, the more they realized that it had effects almost everywhere.
That's why it's of such significance. We think of it as a global climate phenomenon. Droughts in Indonesia and New Guinea, floods in the eastern Pacific and the failure of the fishery there, major winter storms in California, a failed Indian monsoon, drought in some parts of southern Africa, but floods in other areas of Africa. The effects of El Nino are even seen as floods in Europe and Britain. There's nowhere that really escapes.
Scientists now knew that El Nino had effects all around the world, disrupting normal weather patterns, causing death, destruction, and disease. And with this discovery came a new thought. If El Nino could wreak such havoc on modern society, then it must have been even more devastating to ancient cultures. And soon they found evidence of just how destructive it had been. "2,000 years ago, a great civilization ruled the northern coast of Peru. They were called the Moche. The Moche built huge pyramids of mud bricks, created exquisite jewelry, designed stunning pottery. And then suddenly, around 650 AD, it seemed the Moche simply vanished. For archaeologists, it had long been one of the great mysteries. How had such a sophisticated, powerful civilization disappeared so completely, so suddenly? And because El Nino had its greatest effect close to Peru, they wondered whether it had played a part in the Moche's downfall. They needed to find out whether there had been an El Nino around 650 AD. The man who came up with the answer was geologist Nino Thompson. In the 1980s, he went to the Andes Mountains to drill ice cores, and it was these cores that would reveal the pattern of past El Ninos.
As long as the temperatures are below freezing, the ice core records every year's snowfall, and it can give you this 1,000, 2,000, 3,000 year perspective.
The ice is made up of layers of snow that have built up over thousands of years. When it was dry, the layers would be thin and full of dust, and when it was wet, the layers would be thick and clear. By measuring the dust in the ice, Nino Thompson was able to detect which years were normal and which were El Nino years. And when he came to the time around 600 AD, just before the Moche had apparently vanished, he found what he'd been looking for.
If we look at the dust in this period from 565 to 600 AD, this would indicate that there was a major scale El Nino, and that El Nino would have been much bigger than anything that we have seen in the last 500 years.
The ice cores told of a climatic cataclysm, a huge El Nino. And when archaeologists investigated some of the Moche sites, they found evidence that their cities had been torn apart by floods. When they dated this destruction, they found it happened around 600 AD, at exactly the time of the El Nino. It seemed clear that El Nino had begun the collapse of the Moche, helping to destroy one of the great civilizations of the ancient world. It was dramatic proof that El Nino could change the course of history. And once it was realized how powerful El Nino could be, some historians began to detect its influence on all manner of historical events. Take the French Revolution. They said El Nino led to a bitter European winter which caused crop failures and frozen rivers. The result? Starving, unemployed peasants, ripe for revolt. And the Spanish Armada? Defeated, apparently, not just by the British Navy, but by the El Nino of 1587 to 89, which changed the prevailing wind direction, to the disadvantage of the Spanish fleet. El Nino was even blamed for the sinking of the Titanic. The luckless ship found an iceberg in its path after El Nino brought unusually cold conditions to the North Atlantic. For many climate scientists, it's all gone a bit far.
Since the huge El Nino we had in 97, 98, the biggest of the last century, people started connecting everything to El Nino. I mean, everything, you know. Your dog died, it's El Nino, you know. The stock market's crashed, it's El Nino. And so it probably has gone a bit too far.
But that doesn't mean that El Nino can be written off as a historical force. New research is suggesting that at least one other event in history may be related to El Nino, and if so, it carries a very disturbing message. 4,000 years ago, the great city-state of Ur dominated the Middle East. It was the center of the mighty Mesopotamian Empire.
The story of the city of Ur is a dramatic one. Ur was a complex city between 6,000 and 10,000 people. People wrote, they collected taxes. It was a sophisticated, divided society between classes and different occupations, and dependent on irrigated agriculture. But in about 2100 BC, it collapsed.
Historian Richard Grove set out to discover what led to the destruction of Ur. Over 4,000 years on, clues are thin on the ground. But there is one priceless source of information. The British Museum in London holds a series of ancient clay tablets known as the Lamentations of Ur, which document the fall of the city.
This is an important day for me because I'm going to see Dr. Irving Finkel, who's probably the most learned specialist in this country on the Sumerian clay tablets. He can read the script, and we think we may be able to tease out some of the ideas that we've got about the destruction of Ur.
Right, this is the best we can do for the lamentation of the destruction of Ur. They're all written in Sumerian, of course, which is the oldest and the hardest of the languages recovered by archaeology. There are not many people in the world who try to read Sumerian. In fact, you can probably get most of the ones who are reliable at it squeezed into a single phone box.
Now, I'd really like to be able to identify the catastrophic events that actually destroyed the society as it was. Now, can you actually point us to those and perhaps translate it?
We want something rather meaty. Let's have a look here. Yes, we have here in Sumerian, Kengira, maybe Khalam Ede, Gishkhur bi Kurude, which means the storms gather to alienate the divine powers of the rain. This is the first line, but actually it's very damaged on this tablet, to obliterate everything in the universe, to destroy the kingship in Ur. Yes. So everything was going to be overturned.
The texts seem to refer to a series of extreme weather events that ravaged the city of Ur.
Dust and sand have gathered in the waterways of my city gates. Dead bodies lying about for food. No one fetches water. The people had been piled in heaps. In every street, passage, dead bodies were famine.
It's interesting that the texts are actually minutely detailed, and we've got information about the strength of the dust storms and how long they lasted, and the fact that after a long starvation period, if you like, they found the dried up dead bodies in thousands.
It's rather a shocking image, isn't it?
It is a shocking image.
Even though Ur was far from the Pacific, Richard began to wonder if these events were connected to El Nino.
There are very particular features of the kinds of descriptions that we have in the Lamentations of Ur. For example, the descriptions of blood-red skies, skies full of dust that would have been caused by a big El Nino. We have descriptions of shifts in wind direction followed by drought events, boats stranded in the rivers because there was no water, riverbeds being covered by weeds, its irrigation system broke down, it became subject to disease, starvation and famine.
He knew that the biggest El Niños sometimes led to drought in the Middle East, but he needed scientific evidence to show that there was an El Nino of this scale at the time Ur was destroyed. And so he turned to the ice cores, and they showed that at the very time of the destruction of Ur, it seemed there was indeed an El Nino, but not just any El Nino.
El Nino appears to have triggered droughts on an enormous scale. And those sorts of long droughts are recorded in the ice cores, and they chronologically tie in with the timing of the Lamentations of Ur.
The ice cores suggested this was a mega El Nino, a series of big El Ninos over many decades.
It's likely that it describes a series of big El Nino events happening possibly over a period as long as 100 years. Some people call it a mega Nino.
If Richard is right, then the destruction of Ur shows that a mega El Nino can cause devastation on a scale far greater than anything seen in recent years. The question it raised was, could something like a mega El Nino happen again? Scientists realized it was imperative to predict what would happen to El Nino in the future. They needed to know when the next one was coming and how big it would be. This would give those most at risk some warning of what was coming.
If we could predict El Nino accurately, if we had a real way of anticipating the strength of each event, then we'd have the capacity to save lives, save probably thousands of lives, and you'd certainly benefit economies hugely.
And that information could be used by aid agencies. People could be evacuated from areas at risk from flooding, and grain and food could be stockpiled where drought threatened. But predicting El Nino was one of the most complex tasks scientists had ever taken on. They had to monitor thousands of different variables in the ocean and the atmosphere, any of which might lead to an El Nino. They used satellites to watch El Nino from space, tracking the movement of heat in the oceans. And they created a new generation of buoys capable of measuring the smallest change in temperature, ocean currents, even salinity. At the same time, research aircraft crisscrossed the ocean, monitoring changes in wind direction, temperature, and pressure. Even commercial planes were fitted with equipment to gather more information. Then came the difficult part, to make sense of all this information. So it was sent to centres like the Met Office in Exeter. Here they faced a vastly scaled-up version of the problem faced by Gilbert Walker.
When Gilbert Walker was trying to forecast El Nino, he was trying to solve all these equations by hand. Now, using these computers and their incredible power, we can solve billions of them every second. An enormous amount of data is being collected here from satellites and from the buoys that are in the oceans across the Pacific, and we're merging it together with the science, with the models, and it gives us a here and now that we can start our forecasts from.
Millions of variables are fed into a model to see if their interaction will create an El Nino. And after many years of perfecting these models, they're confident they've got it right.
El Nino forecasting is really becoming a big success story, and now as we're moving into the future, we'll be able to forecast up to a year in advance.
That means El Nino should never again catch us unawares. And the implications go further than that. Some people are even beginning to profit from El Nino prediction. For Sid Plant, a farmer in Queensland, El Nino dominates his business.
El Nino is a really big issue, there's no doubt about that. It's the biggest single driver of our highly variable climate in this part of the world, where most farmers think that in 5 years they've got a chance of having 1 or 2 good years, 1 or 2 ordinary years, and at least 1 or 2 terrible years. So we've got to make the most of the good years, and we've got to use our climate skills for that. But I'm also about trying to make some money in the bad years as well.
But Sid has a secret weapon.
I first got interested in meteorology when I got my pilot's licence, when I realised that the forecast for pilots was much more useful than the general forecast was for farmers. And around about then I started taking interest in climatology and the longer term sort of impacts, and started to apply that into farming business. And so my goal is to use my climate skills to stay ahead of the pack, basically, in everything I do. There may be somebody else that's a bit smarter with their financial management, but I like to think I'm pretty much on top of the climatic management.
Sid has used this knowledge to create a new farming strategy. He watches the web closely for El Nino data and predictions.
Generally speaking, I've got probably 400 or 500 websites I watch. I talk regularly to scientists, and I've developed a feel for the way the climate system works for here as well. That I think is perhaps one of the things that gives me the edge.
And when El Nino brings drought, he can buy or sell cattle accordingly.
I'm trying to place myself so that the cattle that I've got here now will be finished and gone to market before it starts to get dry. And I'm trying to position myself so that my grasses and pastures will all be growing. When the El Nino really starts to bite and people are all selling cattle because they've run out of feed, I'll be able to buy cattle, and hopefully quite a bit cheaper than I would have otherwise.
94 half done. The farming, Windara, 4-2 goes to Bindaree 9.
El Nino has completely changed Sid's method of farming. The ability to successfully predict El Nino has given Sid the chance not just to prepare for the worst, but to make money out of El Nino. So he's confident about the future. But his strategy depends on the continuing accuracy of El Nino prediction. And now that success is under threat, because there's a new and unpredictable factor entering the equation, something that threatens to change the very nature of El Nino. Global warming.
There's no doubt that human beings are having an impact on the global climate, and this is causing the climate to warm.
Over the next 50 years, it's thought that global warming will warm the planet by between 1 and 5 degrees. But what scientists don't know is what effect, if any, this will have on El Nino. If global warming does affect El Nino, several different scenarios are possible.
It might be that El Nino becomes more frequent. It might be that El Nino stops. It might be that El Nino becomes persistent and the cycle stops. And any of these alternatives would mean a big change for communities all over the globe.
So scientists began searching for any changes in El Nino, any sign that it might be influenced by global warming. One of them was Roger Stone, a climate scientist working for the Australian government. He decided to examine the recent history of El Nino to see if global warming might already be having an effect. So he went back over the last 150 years of records. And to begin with, there was nothing remarkable.
These are maps of ocean temperatures over the last 150 years. And they show quite clearly, back to the 1880s and before then, that we had a fairly neutral state, if you like, in the ocean temperatures. We had the occasional warming, but that was balanced by the occasional cooling.
The pattern of El Nino stayed essentially the same for more than 100 years. And then he came to the era of global warming, the last 50 years.
Since 1950, and especially since 1970, El Nino events have become more common, and so we see this warming taking place overall in the Central Pacific Ocean. So we had El Nino events in 1982, 1987, 1992, 1997, 2002. But additionally to that, we've had a period between 91 and 95 where the El Nino didn't really go away. And so there's obvious concern about El Nino becoming the norm rather than the exception.
Roger believes these changes suggest that global warming is already having an effect. El Nino seems to be getting more and more frequent.
Global warming seems to be changing the balance, if you like, of the sea temperatures in the Central Pacific. We don't have to have much of a change, much increase in sea temperatures to create an El Nino. It's only 0.5 degree or 1 degree difference in temperatures. So a slight change through global warming in the Central Pacific can have a major effect on El Nino.
The question now is, will these changes in El Nino continue as global warming accelerates? According to Matt Collins, the answer may be a bleak one. He's trying to predict what will happen to El Nino not just next year, but 50 or 100 years into the future.
We use computer models of the climate system in which we represent clouds, ocean temperatures, atmospheric temperatures, rainfall, etc. And we increase the amount of greenhouse gases in those models and try to work out what man's influence on the climate system will be.
Matt's computer model attempts to take into account all the changes that global warming will have on the atmosphere and the ocean. And he uses this to try to predict the future of El Nino. The first thing he looked at was the frequency of El Nino.
We found that when we increased greenhouse gases in our model of the climate system, that the system entered a kind of permanent El Nino state. The warm waters, which are normally in the western side of the Pacific, moved over permanently into the eastern Pacific, and it changed the tropical patterns of rainfall.
It seemed to back up what Roger had been saying. Global warming made El Nino the norm rather than the exception. On its own, this was bad enough. It suggested that the trend towards ever more frequent El Ninos would continue until it became permanent. But that wasn't the end of the story. Matt's model had something far more dramatic in store. Because if El Nino became permanent, there would be a knock-on effect. The action was centered on the Amazon rainforest.
Now, we know that in present day, El Nino is linked to the Amazon rainforest. When there's an El Nino event, there is less rainfall in the Amazon rainforest. But we found in this climate change study that when this semi-permanent El Nino event came along, the Amazon rainforest actually received so little rainfall that it completely died out in about 50 years' time.
The consequences of losing the rainforest would be devastating. It fulfills a vital function in the world's climate system. The huge forests absorb carbon dioxide from the atmosphere, helping to protect us from the worst effects of global warming. On its own, the Amazon rainforest absorbs up to 20% of the world's carbon dioxide each year.
One of the aspects of the Amazon we see at present is that it actually takes up a lot of the CO2 that we're putting into the atmosphere. If it died, it would release that CO2 into the atmosphere and actually speed up the rate of increase of climate change. This is the most devastating impact of climate change we've seen in our predictions.
Global warming would make El Nino permanent. This would kill the rainforest, which in turn would make global warming worse still. And the worse global warming got, the worse El Nino would be. The world's climate would be caught in a vicious circle. It might even lead to the kind of mega El Nino that struck Ur 4,000 years ago.
Big El Ninos destroyed the city of Ur and destroyed a major phase in Sumerian civilization. When we add the possibility of global warming to that story, we have an even more dangerous possibility of devastating climate change.
It's a scary prospect. But there is one chink of light. The computer's result is not a certainty.
We found in our study that there was a 1 in 6 chance of this mega El Nino and the associated death of the Amazon rainfall. Now, 1 in 6 isn't a very high probability, but it is a very high impact event. So the cost to society and to the environment could be very large. We need to ask ourselves whether that's a risk we're willing to take.
The trouble for scientists, and for us, is that no one yet knows if the computer models are underestimating the danger or being overly pessimistic. But what scientists do agree on is that El Nino is immensely powerful and that it is sensitive to climate change.
What we're doing now is we're running an experiment which hasn't been run before. We're going into uncharted territory because we are going to heat the planet. We're going to heat it to warmer than it's been for probably millions of years. And so we simply don't know what's going to happen. But in my view, we should not change the climate. We're poking a sleeping dragon.
If global warming continues, El Nino will change. We've thrown the dice. Now all we can do is wait and see what happens.
Join us next week for a look at the awesome power of nature, its cause and effect, and our limited knowledge of it. Enlightening Nature Strikes Back, next Wednesday morning at 11 on ABC One.